Hello everybody, and welcome to the Fall 2013 Pavinar webinar series. My name is Andrew Braham, and I'll be leading the Pavinar today. As you'll notice, if you've been a member before of our webinars, we do have new software this year, and hopefully no one had any problems or complications logging on. Some of the old rules are the same though. If you have a question, I encourage you to raise your electronic hand, and you can find this hand just above the list of participants on the left side of your screen. And then if you could please type your question into the chat box after raising your hand, I will answer it either immediately or at a convenient break. But if your hand is raised, I'll assume that you are typing the question in the chat box. In addition, professional development hours will be emailed to you after the presentation. So today we're going to talk a little bit about the use of recycled asphalt shingles. And we were specifically asked, I believe it was by industry, to cover this topic. Yes, it was requested by industry to cover this topic, and it's an extremely broad topic. So today will be quite a survey, and it does go all the way through the processing to the plant production. So there's a lot of breadth, but not an excessive amount of depth in today's presentation. So we'll start out with some definitions. What are recycled asphalt shingles, or RAS, and what are some of the benefits of those? We'll talk a little bit about processing RAS. There are 5 different steps: collecting, sorting, grinding, screening, and storing. We'll talk about the lab characteristics of RAS, and this will go from the properties of the RAS itself to incorporation of RAS into the mix design, and then also to the lab performance of mixtures that have RAS incorporated into them. And then finally, the 4th and final section will discuss the production, the construction, and the field performance of RAS. So the first question is, what are recycled asphalt shingles? And there's 2 general types when people are talking about recycled asphalt shingles. There are what are called post-consumer shingles, or tear-off shingles, and these are shingles that have been in use in the past, either on houses or in other applications, and then when they need replacing, obviously the old ones need to be ripped off, replaced with new ones, and it is possible to use those old shingles in asphalt concrete. And that's called either post-consumers or tear-off shingles. The second type is manufactured waste shingles. And these are shingles that come directly from the manufacturer of the recycled or the asphalt shingles. And these can either be punch-outs from shingles. They have these large sheets of shingles and they punch out certain shapes, or anything that may be slightly out of spec for the roofing application. That can be another form of manufactured waste. In general, manufactured waste shingles are preferred because there's only grinding required. You have minimal sorting, inspection, testing, and separating. And also you tend to get a more consistent product. That's another benefit to having the manufactured waste shingles. Now, unfortunately though, manufactured waste shingles are not nearly as prevalent as post-consumer shingles. You can imagine that the manufactured waste is kept to a minimum. That's money that's not being earned by the shingle manufacturers. So there are plenty of post-consumer shingles. Some potential problems, though, include asbestos, deleterious materials, and then also the asphalt is highly oxidized. And you'll see that even normal asphalt in the manufactured waste shingles has a very high stiffness. The tear-off shingles are even higher. Now, the Texas Transportation Institute put together an extremely nice report on this topic, and the majority of this presentation does revolve around that report. So I'm putting the link in the chat box. You're not able to click on the link in the webinar software. So the link has been provided in the chat box, and if you're not able to access it there, you can also go online after the presentation has been posted. These are the components of recycled asphalt shingles. You can see we've got two different types being described here. We have organic shingles and fiberglass shingles. The asphalt cement type, or the asphalt cement percentages, is higher in the organic shingles, approximately 30 to 36% versus 19 to 22%. The reinforcing mat for organic shingles is approximately 2 to 15% by weight. So this is the material that's underneath the shingles that you can see, and that's the same for fiberglass shingles. The mineral granules or aggregate is approximately 20 to 38%, and the mineral fiber or the mineral granules and the mineral filler are actually mixed together with the asphalt cement, and that's what makes the shingles that we can see. And the second half of that, the mineral filler, is approximately 8 to 40%. And then any sort of adhesives that you need in order to have the shingles adhere to the roof is approximately 0.2 to 2%. So this is just kind of an overall picture of what are the components of recycled asphalt shingles. And you can see from our perspective, incorporating RAS into asphalt concrete, the asphalt cement and then the mineral granules or mineral filler are really the things that we are most interested in, because those are things that can actually add value to the RAS as a part of asphalt concrete. These are some of the benefits of RAS. There are environmental benefits. You can divert shingle waste from landfills, and your need for virgin asphalt and virgin aggregate, that mineral filler and the small mineral aggregate, is reduced. You have some cost benefits because you're not only reducing your virgin material needs, but then either the manufacturer of the shingles or the people disposing of tear-off shingles don't need to pay landfill fees as well. So it's kind of a win-win situation. Someone's trying to get rid of something that they usually pay to get rid of. Someone's trying to get something they usually pay to get. So there'll be some savings on both sides of that. And then also there's the theory of you have some pavement benefits too. So what I reviewed, some people say it increased rutting resistance, it reduced cracking. Overall, I never saw any argument saying you did not get a stiffer mixture. So you will certainly get a stiffer mixture using RAS. However, the rutting resistance and the cracking, those are things that I've heard going both ways. So we'll see agreements and disagreements with some of these statements throughout the rest of the presentation. So if you have any questions, please raise your electronic hand. Type your question into the chat box. I have gotten a couple of messages about not being able to hear at this point. Thank you for those messages. I would encourage you to obviously check the volume on your computer, and if that doesn't work, you can go to Tools, Audio, and Audio Setup Wizard, and that can also help you if you're having trouble hearing. Well, since there's no questions, we'll move around. We'll move on from the background to the processing of the recycled shingles. So there are 5 general steps to processing RAS. The recycled asphalt shingles, or RAS, need to be collected, sorted, grind, screened, and then they need to be stored. And we'll look at each of these practices in more detail. There are 2 basic strategies in order to obtain high quality, clean, and sustainable RAS. So if pavement contractors are looking to actually obtain a steady stream of high quality RAS, you want to make sure that it is somehow separated. And this can either be done at the source So the roofing contractor needs to separate the non-shingle debris out of the shingles themselves before transferring them to your plant. Another option you can have is by actually collecting the mixed roofing material, and at either a recycling facility or even at an asphalt plant, that's where you do the sorting. But either way, you do need to sort you need to minimize any sort of non-RAS material. And those type of things can include cementitious shingles or siding. If you're on a construction site, you can have different types of shingles. And also, because it's a construction site, you may find siding or other components of construction within your RAS. You certainly need to get rid of any hazardous waste, and some common items at job sites include thermostats, paints, or solvents. If these get mixed in with your RAS, these can create problems with the plant and potentially in the field. And then you want to eliminate any sort of trash, and that includes any sort of plastics, paper, glass, or metal. So construction sites, there are always a lot of things going on, and sometimes some contaminants get into the RAS, and you want to minimize that as much as possible. Now, some of the especially older shingles do contain asbestos, so if you are considering using RAS, they do recommend that you put together some sort of asbestos management plan. So if asbestos is found at some point within your material stockpile, you have a plan on how to address that and to get rid of it. So for the first step is sorting the second step, excuse me, is sorting the RAS. As I mentioned, if you're using manufactured waste, this is not a very intensive process because the material that comes from the manufacturer of shingles tends to be a lot cleaner. But if you do have tear-offs, one of the most frequent ways to sort is just simply manually. And this is a tremendous time investment because, as you are well aware, these stockpiles of materials are quite significant, and to physically sort through by hand is not a small undertaking. And this needs to be done because you want to get rid of construction site waste, hazardous materials, and other trash, as mentioned on the previous slide. Now, there are some things that you can do. For example, if you believe that there's a significant amount of metal in your RAS, as nails are used to put shingles on often, you can put a magnet by a conveyor belt. And in theory, that should attract the majority of the metal. You can also consider washing the RAS significantly. That will degrade any sort of paper products. But at the end of the day, you probably do need a physical set of eyes and hands on the material in order to make sure that there's no deleterious material within your RAS. And you can see in this picture here, there's 4 stations to this RAS production. You have a newly started RAS pile on the left. There's been no testing done on that. That's things that was just delivered. On the right is a sorted pile, but it's unclean. So there's quite a bit of material still in there, non-RAS material. In the center is a sorted clean pile. So in theory, that should only have shingle material. There's no other material in there. And then it goes through some sort of grinding operation. And on the far left, you have your process piled, the finished product, which is what you'd end up putting in your pavements. So when you're talking about, you first obviously need to collect the RAS, then you need to sort it. The next step is to grind it. You want to get it down to specific sizes. And in all the literature that I observed, really less than a ½ inch is often the maximum size. If you grade the RAS to smaller sizes, you are able to increase your RAS content. It makes it easier for it to blend into your asphalt concrete. And you can do that by using shingle grinders or shredding machines. There's 2 types that I found in literature, either a rotary shredder or a high-speed hammer mill. And then after it's grinded, there's some operations included in that. You need some sort of hopper to load the material. You need to feed it into the drum. It gets ground, and then it comes out on the other side. And within the grinder, you have your cutting teeth, and then you have some sort of sizing screens as well, because you do want to make sure that you're not getting either oversized material or you're getting the gradation you expect, which is why you want those sizing screens at the end of the grinding chamber. One of the things I was reading about that was a potential concern was heat during the grinding process. Obviously, a lot of our work takes place in the summer. There's a lot of sunlight, a lot of heat builds up, and grinding RAS can get very literally sticky if you're not careful. And they say that you can use water to keep the shingles cool, but a big disadvantage of that is that you'll have additional costs for the drying on the other end, because at the end of the day, before you put the material into a drum, you do want to minimize the amount of water you have. So you can use water to keep the shingles cool, but then you'll have additional costs for drying afterwards. So for the screening process of wrap, they recommended a trommel screener, which is a brand of screen or a type of screen. And you can customize the size of process, and excuse me, that should be RAS, not wrap. The second bullet point, you can customize the size of your processed recycled asphalt shingles. Just like any aggregate source, you can pretty much do whatever you want. And the rule of thumb is that you want to try and get it certainly less than 1/2 an inch, but even going smaller to 3/8 of an inch can improve the blending with the asphalt concrete. Now, if you continue to grind and continue to get to smaller sizes, that's again probably going to be an increase of cost, but you may see an increase in the quality of your mixture as well. The final step of processing RAS is the storage of RAS, and it's very similar to RAP, recycled asphalt pavement. But however, because of the small size, it does absorb a significant amount of water. Just less than 1/2 inch, possibly less than 3/8 of an inch, really does lend it to absorbing water. And if you have water in your RAS and it goes into the mixture, the asphalt concrete mixture, that can lead to inadequate coating, compaction, and poor performance. Another thing to keep in mind is that depending on where your sources of recycled asphalt shingles are from, you may need separate stockpiles. A previous slide when we were talking about the components of RAS, the fiberglass shingles were 19 to 22%, while the organic shingles were 30 to 36%. That's a pretty significant difference in percent weight of asphalt cement within the RAS. So if you're getting multiple sources of RAS, it may be beneficial to have actually two different, two, three, or more different stockpiles as well. A special concern of RAS is that it can agglomerate during static storage, and agglomerate essentially means it starts to reclump together. So you can see a very nice stockpile of RAS in the upper right-hand corner, but especially down toward the bottom where there's a lot more pressure, it can actually start reforming into larger particles. And that's due to the high asphalt cement content, and it's obviously due to the size of the stockpile and also the temperatures, the ambient temperatures. One of the suggestions to combat that was to mix with a small amount of sand. If you mix it with sand, that'll prevent the RAS particles, or it will reduce the potential for the RAS particles to stick together, and you can avoid some of that agglomeration. So the processing, it is 5 parts. There's the collecting, the sorting, the grinding, the screening, and the storing. So I'll take a quick break here. If there's any questions, please raise your hand and type the question in the chat box. Well, I don't see any questions, so we'll continue on, going from the processing to some of the properties of recycled asphalt shingles. So there are several properties that we would like to look at. That includes the gradation of the processed RAS, and also the gradation of the RAS aggregates. So just like with RAP, recycled asphalt pavement, there are differences between the processed RAP gradation and then the gradation after RAP goes to the ignition oven. It's very similar with RAS, recycled asphalt shingles. So the gradation of both the processed and the unprocessed is important. The binder content of the RAS is important, and then the binder performance grade. So after an extraction and recovery, what is the performance grade of your RAS? Another important lab characteristic of RAS is the mix design. How does the incorporation of RAS influence the mix design? And then finally, the mixture testing. So at the end of the day in the laboratory, what sort of property changes are there when you include RAS in your mixes? And I've said it a couple times, but it's certainly worth repeating. The finer the processed RAS, the better potential for mixing with the virgin binder. So when you're looking at the gradation of the processed RAS, you use ASTM C136, which is a sieve analysis of fine and coarse aggregates. That's just a standard sieve analysis. If you look at tech stock specifications, you want 100% passing a half-inch sieve, 95% passing the 3/8-inch sieve. And then Iowa took it one step further, and they looked at both coarse and fine process wrapped. So the coarse RAS. The coarse RAS has 100% passing the 3/4-inch sieve. It has 98% passing the half-inch sieve, and then 94% passing the 3/8-inch sieve. So there's a little bit of opportunity for maybe 1 or 2 half-inch or larger size particles in the coarse gradation. And then the fine gradation is obviously a little finer, and you have 100% passing that half-inch sieve, 99% passing the 3/8, and then 82% passing the number 4. So basically it's one step down, one sieve size smaller for the fine versus the coarse, according to Iowa. When you're trying to determine both the gradation and the binder content of RAS, you can use 2 methods. You can use either the ignition oven or you can use extraction in order to get the gradation and binder content. So there's been some work done with the ignition oven, and they found that the 1,300 gram sample size was too large, according to ASTM D6307. Because there's such a high percentage of asphalt content, even though they ran the material multiple times through the ignition oven, not all of the asphalt was actually burning off the sample. It was just too large of a sample with too much asphalt in order to get it all off. So Texas recommended actually using 500 gram samples. They found with the 500 gram samples you had a complete burning of all the asphalt cement off the RAS material, but you were still able to get consistent results. And that's probably partially because you're using that finer material, so you don't need quite as large of a sample size with a finer gradation. The extraction mechanisms, ASTM D5404, I did not find any guidance on sample size. I would assume, though, similar to the ignition oven, the larger the sample size, the more work it is to extract and then actually recover that binder, just because you're dealing with such a high concentration of asphalt cement. And you can see down here in observation, there's a spelling error in here, I apologize, but tear-off shingles have a higher binder content. So it's not bonder content, it's binder content. So the tear-off shingles are usually 24 to 28%, whereas the manufactured waste shingles are a little lower, they're 20%. In addition, the tear-off shingles have a coarser gradation. So tear-off shingles in general have higher asphalt content and also a little coarser gradation when you're comparing it to the manufactured waste shingles. Once you have extracted the asphalt cement from the RAS samples, a lot of people like to recover that and run some super pave or some asphalt binder tests on that recovered material. Now, some processing notes when you're running the recovery, some people have found that you do want to run the recovery at higher temperatures, up to 200 degrees Celsius, because you need that high of temperature to have the asphalt cement that's been recovered actually flow out of that beaker, just because it's such a stiff material. So you may see an increase of temperature there. Another thing you may need to do is increase the testing temperature of your DSR. That's also been known to have to reach 200 plus degrees Celsius in order to actually grade the material. That's kind of on the high temperature side. On the low temperature side, I wasn't able to find any studies that were actually able to quantify the lower binder grade. Excuse me, I take that back. I found one that had a +2 degree lower binder grade. But a lot of people were having troubles getting their M value to physically reach 0.3 because the material was so stiff. So those studies that found that, they just assumed that it was above 0 lower binder grade, but they didn't necessarily grade that out. And you can see here on the last bullet, the PG binder grades have been anywhere from 136, 118, all the way up to 203, and then plus some number. So I do recall seeing 1 plus 0.2, and that's not a typo. That plus sign means a positive lower binder grade temperature. So it's a very, very stiff material, and with such a high asphalt content, it's certainly something that you need to take into account. So with the mix design here, I'm going to actually pull something out of a folder I have next to me. When I was making the presentation, I didn't get it referenced. But with the mix design, the research I looked at really didn't find any significant difference between mix designs with or without recycled asphalt shingle. You just want to make sure that you're getting your proper binder content and gradation using the ignition oven of your RAS, and then you're getting the proper binder properties using extraction and recovery. Now there is an AASHTO standard, and I'll type it into the chat box here. AASHTO, let's see, PP 53-09. So AASHTO PP 53-09 is design considerations when using reclaimed asphalt shingles and new hot mix asphalt. So there is kind of some guidance here. Unfortunately, I didn't go over this document before the webinar because I didn't recall that it existed. But I encourage you, that does have some tips in there about design consideration when using RAS. And I think that standard alone could be an entire webinar, so I'm not going to go into too many details there. Overall, though, there are some challenges to using RAS. When you're using the mix and working with the mixes tend to be very drier and stiffer, which can lead to an increase in cracking. There's a lot of questions surrounding how much blending there is between the virgin asphalt cement you're using and then the RAS binder that's being added to it. And this is also a topic I think that's pretty open with recycled asphalt pavement RAP. So both RAP and RAS, I'm not sure if we fully have our heads wrapped around how much does it actually blend together. Obviously the RAS gets heated up partially during this manufacturing process, but then when it hits and comes in contact with the fully heated aggregate and then the asphalt cement, we're not sure how much it actually blends together. In the lab, it's very easy to heat up asphalt cement, add the RAS, and then just continuously stir and stir and stir to make sure it's fully blended. But in a plant, you have a lot less contact time. It's also very difficult to simulate the RAS field heating in the lab, both time and temperature-wise, so we're not quite sure how that affects the blending. Because we're not sure of the blending, the mixing and compacting temperatures aren't 100% nailed down. Mixing and compacting is now determined using the Brookfield rotational viscometer. And if you have a fully blended asphalt cement, that would give you a much different mixing and compacting temperature than if you had the virgin asphalt cement with some, you could almost say like larger clumps of the RAS binder that's not fully mixed into there. And then finally, this is a huge one, and from a research perspective, we always get excited about these type of topics, but when you start reducing the production and construction temperature, that makes it even more difficult for the RAS to blend in with the asphalt cement. So there are a lot of open questions. We've got the AASHTO PP53 spec, which provides some more nuggets. Again, I'm not going to go into those details. But there's a lot of things going on here with the mix design. And then finally, the lab performance. I looked at several reports, and this is just kind of a summary of some of those reports. Some people up at Illinois, they looked at RAS and stone matrix asphalt, and they found that the inclusion of RAS decreased the dynamic modulus, which indicates that the RAS is stiffer, but it increased the wheel tracking test, which indicates that the RAS is softer. So you've kind of got a contradictory results there, or a discontinuity. But I'll provide the link in the chat box. Illinois also did a report using RAS and RAP at a total of 43 to 64% binder replacement, so kind of going for those higher levels. Here they did find that adding RAS decreased the wheel tracking test, which indicates that the RAS stiffens the mix. It did not significantly change the cracking, and that's very important. One of the worries about using this stiffer material in a mixture is that it will be more susceptible to cracking, and this study did not find that. And then it did see a decrease in fatigue performance, which again indicates that the RAP was a stiffening agent. And you can find that link also in the chat box. And then finally, Iowa State came up with this statement. I thought it was a nice positive way to end the section, that RAS can be successfully produced and meet state agency quality assurance requirements for asphalt, for mixed asphalt content, gradation, volumetrics, and lab performance testing. So I'll also provide a link to that report. So those are the 3 links that we have here. And I think overall we've got some contradictory statements up on top, but then there seems to be a very strong path forward for this. So now we're going to move from the properties of RAS to RAS and asphalt concrete, and I'm going to scroll through the chat box here. I believe there's been a couple of questions, so if you bear with me now. The new software actually shows the time everyone joined, which is interesting, but it kind of makes you have to dig through a little more information. So we had a question from A. Rahim, and the question is, for the PG grades mentioned, are these for RAS binder tested in DSR at 200C? And the question, or the answer is yes. So what we're referring to here, I'm going to go back a couple slides. These RAS performance binder tests, they did have to be tested at these higher temperatures in order to grade them out at that. So that is why we have the second bullet in here. DSR temperatures need to reach 200 degrees Celsius, because you can see that some RAS is only a 118 or a 136, but then they do get up to 157, and one has even been graded up at 203. So yes, your DSR does need to get up to those temperatures in order to properly grade the asphalt cement. So I'll take a second here. If you have another question, please raise your electronic hand, and I'll know to wait. Well, there don't appear to be any other questions. I've recognized that there are some people on the webinar from Texas and from Illinois, and if you have anything to add to what I'm saying about these reports, please feel free to hop in with a point on the chat board, because if you are actually participating in some of this work, that probably means you have a much deeper understanding. So, or even if you hadn't worked on one of these reports, if you've had some experience with recycled asphalt shingles that you'd like to share with the group, please feel free to raise your hand and type it into the chat box, and we can have a little conversation about that as well. So the next question is from Marty Burrow, and the question is, can you blend recycled asphalt shingles, asphalt cement, with a softer AC of known grade and back calculate the RAS grade? And I think that's an excellent question. So if you know a binder grade, a soft binder grade, and you blend a harder binder into there, and you get a new binder grade, assuming it's a linear relationship, and you start getting on kind of shaky ground because asphalt cement's not a linear material. It doesn't, the properties don't change linearly with time or temperature. So the question is, can you back calculate a RAS grade from a blended material? And I would say that could give you an indication, but I would be extremely hesitant to put any sort of firm number to that because, like I mentioned, asphalt cement's not a linear material, so it's not like a one-for-one switch necessarily. It's a nonlinear material over temperature and time. And the second thing is that I think if you were to do that, you'd have to assume 100% blending. And I think that would be a pretty significant assumption to make as well. So I think it could give you an idea of where it may be, but I certainly wouldn't want to assign an actual binder grade number to it using that method. All right, so our final section will be using RAS in asphalt concrete, a little bit of field experience as well. So when you're looking at the production and construction side of things, RAS is typically treated like RAP. We've talked about this a little bit in previous slides. You want to have good stockpile management. You want to make sure it's clean. You want to make sure it's covered to avoid that water getting in there because it's a smaller particle. But there are 4 specific issues in the mix production that I was able to find. One, you want to make sure to keep the RAS bin empty when not in use. So when you're looking at adding another aggregate source, you're going to have a bin, a feeder bin for the RAS material, just like you have one for each aggregate type if you have a drum plant. You have one for each aggregate type, and you have one for the RAP. You want to keep that RAS bin empty. You don't want RAS sitting within that bin. Another thing is that you would like to use a vibratory scalping screen to break down or remove any clumps. So even when you're transferring material from the stockpile to the bin, you would ideally like to have a vibratory screen on there to break down any clumps, to avoid getting any of those agglomerated particles into your mix. You certainly don't want to superheat the mix. There's a lot of asphalt cement in there, 20% plus, so superheating it can cause severe problems with your final product. And then they also don't recommend you hold the RAS mix in a silo overnight. I'm sure there's a lot of not good things that could happen. It could stiffen up in the silo. It could become hard to work in the field, hard to compact, so you want to avoid doing that. Some similar trends with the construction side of things. Again, you typically treat RAS mixtures like you do RAP mixtures. There are some specific issues that they called out, and there's the usual. You want to be cognizant of the weather, the haul distance, the time that the RAS mix is seen in the trucks, and then also the temperature at the screen. All of these things are considerations. Some of the reasons for that is mixtures that contain RAS tend to stiffen more quickly in the trucks versus standard hot mix. And that's very similar to why you don't want to keep it in silos. These RAS mixtures could have tendencies to stiffen more quickly than you're used to. Keeping things overnight or keeping them in trucks for extended periods of time could create problems. Another offshoot of that stiffer mix is that it is more difficult for handwork. So a lot of times you go out to job sites, you got a lot of handwork going on, either on corners or just kind of fixing small problems. If you use RAS, it can be more difficult to do that handwork. And then also finally, the mat can be more sensitive to temperature segregation. So I think it's strongly suggested that if you're doing a mix with RAS, you certainly have a material transfer device on site, because that will allow for a remix of the material to try and minimize any sort of temperature segregation that you can have coming off the back of the screed. So Iowa State put out an extremely comprehensive report, and it was a pooled fund study. So they had 7 projects, one in Missouri, one in Iowa, Minnesota, Indiana, Wisconsin, Colorado, and Illinois. So I'll put that link in the chat box. And so what they did is they went out and they looked at the entire process, all the way from the design to the production to the construction, and then 2 to 3 years of field observations as well. And either fortunately or unfortunately, depending on how you look at it, they really weren't able to see any consistent trends when you included RAS in your mixes. Some sections across those 7 states saw higher reflective cracking, some saw higher transverse cracking, but then some sections actually showed lower cracking. So there's kind of a mixed bag there, and that can either indicate that RAS really doesn't have an effect, maybe something else is driving it, maybe that there's another behavior of that material that kind of overpowered the RAS, or it may mean that the addition of RAS, and I believe that none of these were more than 5 or 6% RAS by weight of entire mix, so maybe there wasn't a high enough level of RAS to actually influence the end product. Some sections did show higher raveling. That may go back to the fact that you don't have full blending going on, and if you have these shingle particles that aren't fully blended and those are up at the top of the mixes, then that could start raveling off, and if you're expecting that asphalt cement content to help hold the aggregate together, then that would actually lead to potentially further raveling as well. So raveling is something to keep on your mind. And then finally, some sections you didn't see any difference between the sections that contained RAS and the sections that did not contain RAS, or the control section. So it's really kind of a mixed bag. There's no consistent trends. Some did the same, some did a little better, but in general they were either the same or they had some additional problems. So that's kind of, at least from these field sections, the 2 to 3 out, what was found. Now I think it'll be interesting over the next 5 to 7 years if they continue tracking these sections to see just how well these sections do and to see if any more conclusions can be drawn. And Iowa State team concluded saying that RAS is a viable option based on these 3-year surveys. So very short term, but showed some promise. So in summary, I'll just go over the logistics first, and then I'll open up the floor to questions. We've got quite a bit of time here. But professional development hours will be emailed to you after the presentation. And our semester started last week, so there's quite a bit going on. My goal is to get those out no later than Friday, September 6th. If you don't get them, feel free to send me an email reminding me. You can rewatch the Pavinars through the website, and you can either rewatch the actual recorded session or you can download the PDF presentation. Both those will be available, again, no later than Friday. We've got a great slate of topics this fall. 3 of the 4 topics were suggested. I think that's great. This was one of the ones that was suggested, and there's 53 people that are here today, so it's obviously a salient topic. So please, if you have topics that are interesting to you, shoot me an email, submit them via the website, and we'll make sure to get those on next spring's webinar list. And the next Pavinar will be Tuesday, October 1st, and it will cover SAMIs, stress-absorbing membrane interfaces, and also other stress relief asphalt layers, and that was requested by the Nevada DOT. So we were able to go around the background, the processing, some of the properties, and also some field projects. Looks like we ended a little early, so I'd be more than happy to stick around if you have any questions. I encourage you to raise your hand and start typing them into the chat box. But if you don't have any questions, thank you for joining us and hope to see you again next month. Looks like we got a couple questions, so please type the question in the chat box in the left-hand corner, and I'll answer them as they come in. The first question is from Nick, and it says, any thoughts on using warm mix asphalt foaming technology and RAS? And I think that the biggest, I shouldn't say concern, the biggest thing that comes to my mind when you're thinking about using any warm mix technology is the fact that you're not getting as high mixing temperatures in the drum for that the blending of the RAS asphalt cement and the virgin asphalt cement. Now, it's my impression that we haven't had a whole lot of problems using RAP with the foaming techniques, with warm mix foaming techniques. But I think something to be a little more cognizant of is that recycled asphalt shingles have about 4 more times asphalt cement in the shingle material versus the RAP. So I think that if there are problems with blending, they would come out much more strongly with the RAS versus with the RAP. So I haven't heard anything in particular about foaming and RAS. Like, I haven't seen any of those combined together, but I do think that in general, RAS with the higher binder content, you could have some potential problems with the blending. So the next question was about asbestos testing, and I think the only thing I found about asbestos testing can be found on slide 10. So I'll go back to there. So the question was asbestos testing for shingles. The only thing I found was that there is a chance for asbestos to be in the shingles, and they recommend you develop an asbestos management plan. I also do want to report or highlight that the Texas Transportation Institute, TTI, in the report that I have the link, I just put the link in, they did have a section on asbestos testing. I didn't get into that too much, but if you go to that link and download the report, you are able to find that there's a couple pages on specific asbestos testing recommendations. I just didn't put that into this presentation. Another question from Larry Weir is the relative cost benefit of the use of RAS over virgin materials. And Larry, that's an excellent question, and I think it's one that's very difficult to pin down. If you're looking at up to, if you're using 5%, if you're using 5% RAS in an asphalt concrete mixture, about 20% of that is asphalt cement. So you're looking at about adding 1% asphalt cement to your mix. So if you have a 4 to 5% asphalt binder content, that is a potentially 75 to 80% virgin binder, and then 20 to 25% RAS binder. Now, I believe asphalt cement, gosh, I don't know what the price of asphalt cement is a ton. I'm sure some of you on here know better than I do. The cost of asphalt cement per ton, let's see what that is real quick. Well, the first thing that came up with Google is between $200 and $500 per ton, which is quite the range. But let's just say it's on the lower end of that, $200 a ton, and you're saving perhaps 20%. that's anywhere from $40 to $50 a ton of mix. You could potentially save, and that's assuming 100% blending, and that's assuming that you're getting the asphalt cement properties that you want out of that 100% blended material. So potentially $40 to $50 a ton, but I think that's a very high-end value, and then that doesn't include the cost of obtaining the material and then the cost of processing it, making sure that everything's ready to go, grinding it, and then, of course, any sort of plant improvements. So another comment is that the asphalt used in shingles is typically air blown, and I did not point that out. Thank you for bringing that up, Steve. So the asphalt process to make shingles, you air blow the asphalt cement, which is what makes it so much stiffer, and that accounts for the very high PG grade. So it's not like they're taking the asphalt cement that we use in the paving material and just mixing it together and putting it on the roof. They do have this extra step of air blowing it because they want the asphalt cement to be stiffer on a roof. They don't want it to be able to move at all like we do with flexible pavements. So they do air blow it, which accounts for that stiffening effect. Oh, and we got 6422. The price now is $530 a ton. So I guess that is a pretty high range. So Larry, going back to your question, if you kind of assume that full blending, you're saving 20 to 25% of your cost, that's starting to get up to $100 a ton, $100 plus a ton. So thank you, Chris, for that that price quote. Much more accurate than Google. But I guess if you're using shingles, you could conceivably save up to $100 a ton. Now, again, there's additional costs associated with that, getting the material, processing it, and then any sort of changes you have to the plant. There's an additional potential risk in using a new material that doesn't have proven field performance, but there are some potential for cost savings there. All right, well, are there any other questions? If there are any questions, could you please just press on the electronic hand? All right, well, it doesn't look like there are any questions, so we're ending early. We get out of class early. That's always great. But thank you all very much for joining us, and I hope that you are able to join us on October 1st. And also, please do submit topics for next spring. Thanks a lot, and have a great afternoon.